Section 2.1. Inductive reasoning and conjecture. First thing to talk about, inductive reasoning. Is a conclusion you draw using a specific number of examples. Is a conclusion you draw using a specific number of examples. Okay. The conclusion you come to is called a conjecture. Everybody get your workbooks out. Let's look at number 1 on page 15. We're going to use inductive reasoning to figure out what the next thing in the sequence would be. Next term. Wish they had commas in between those. I'd rather them do that. But, okay, looking at this. One thing you can kind on some of these pictures, if what you start here isn't what I outlined in red here, what we had the time before. So we added what? 3 blocks, 2 shaded, and the one in the middle non-shaded, right? Okay, the next one. This all basically what changed and how did it change. That's what we had the previous time, correct? So what changed? Same thing, we added what? 2 shaded blocks here and then 8 non-shaded here. So if we were going to write out the next term of the sequence, it's going to be what we have, which now is what? 3 of them? I know that's not the best drawing in the world, but it's the point that matters. Shade, 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 shade. Shade, shade. I know. This is what we started with, right? What are we going to add to it? We're going to add basically 3 right there, aren't we? We used inductive reasoning. We used a specific number of examples to come with a conjecture. Make sense? Now, let's look at number 2. Sometimes they're going to be very easy, but basically, look at it like this. Okay, how could I get from -4 to -1? Tell me a way to get there. Huh? If I added 3 to it, I'd get there, wouldn't I? See if that works for the next. From -1 to 2. If I added 3, does that get me to the next one? Okay, so we got 2 in a row here. Let's try the next one. If I add 3 to the previous, does it get me to the next one? If I add 3 to the previous, does it get to the next one? So what's our pattern here? To what? If they ask what you're doing here, you say add 3 each time, right? And if they wanted the next term in the sequence, it would be what? 11. Correct? Because we're adding 3 each time. What would the one after that, next one after that be? What about this next one? The dreaded fraction. Anybody have an idea what's happening each time? A lot of you are probably having problems seeing this, correct? And I don't blame you. What I did in my mind is, well, which makes more sense to you, 11 over 2? Or if you wrote that as a mixed number, it'd be 5 and what? 9 over 2 or what? Now is it kind of easy to see what's happening each time? What are we doing? Subtracting 1/2 each time. I agree wholeheartedly with putting him in this form. You're going to find as you get into higher level math, improper fractions are much easier to deal with than mixed numbers. But mixed numbers do have their use. For graphing, if I tell you to go to the right 6 and up 11 over 2, what makes sense to you? Go to the right 6 and up 11 over 2, or go to the right 6 and up 5 and 1/2? Up 5 and 1/2, right? Gives you a better sense of the number. Agreed? So but it's hard. You can't multiply with it like this, right? You got to change it to an improper fraction. So, anyhow, starting to see the pattern here. Number 4, is there a pattern? Well, to get from here to here, I could say I added 6, couldn't I? Would you guys agree? If I added 6 to 4, would that give me the -8 though? No. So right now that doesn't work. Okay. If I look at just the numbers 2, 4, 8, 16, 32, what's happening? You're multiplying by 2. But what's 2 times -2 is what? Huh? -4? So that wouldn't quite work. I can get the numbers, so what else could I try? If I multiply by -2, -2 times -2 is a positive what? +4 times a -2 is a -8 times a -2 is a Positive 16. Positive 16 times a negative 2 is a? So when I multiply by 2, again, what am I going to get? A positive what? Anytime the signs are changing like this, you're probably multiplying by a negative, aren't you? Each time. They'll also ask you to do things like conjectures like this. They ask us make a conjecture about each value or geometric relationship. Points A, B, and C are collinear, so they're all what? On the same line. D is between B and C. What do you think I could say? So you've got A, B, C all on the same line, and they say D is between them. What's the only thing you could probably say here? What did we learn in the last chapter about them being what? Between, right? We don't know whether A's here or whether A's here. All we know for sure, A could be here, A could be right here. We just know that it's on the same line, but we do know for sure that D is between what? So, what do we know? I would make the conjecture that BD plus what? DC is equal to the whole thing what? Isn't that what they're leading you to? Because isn't that what being between something means? Isn't that what we learned in the last chapter? That's the conjecture I would make. Mm-hmm.
And working it out is just writing a line.
You don't have to have that. That would be fine. Point P is the midpoint of NQ. So what does that mean? And some of you may need to see it. So the situation is you've got N and Q, right? What are they saying about P? It's exactly in the middle. So what does that mean? These are equal. So what could I say? NP is what? Or segment MP is what? Congruent to segment N or PQ, correct. That's probably what they're wanting to lead you to. However, it would be okay to say this. Do you see the difference in the two statements, but really why both of those are correct? This leads you to this, but I could see if you saw that too. But that's where they're trying to lead you. Okay. And some of these, I could see being confused here and maybe getting one of two answers. When I see this, angles 1, 2, 3, and 4 form 4 linear pairs. To me, that means 4 sets of 2, correct? So to me, this is the situation you have here. Right? What else? And the last one. See the 4 linear pairs created? Unfortunately, there may be some of you that might do this. That's actually wrong. But you'd be kind of thinking on the right lines if you did that. You see what I'm saying? Do you see why? But see, that's not four linear pairs, is it? That's just four angles that form. Because see, these two aren't. Do you see why that's wrong? Were any of you thinking this? Okay. Then no need talking about it. Do you see how that's four linear pairs? Right here, if angle 3 is congruent to angle 4, what do you think we can say about the measures of those angles? Anytime they're congruent, I mean, I did it right up here. Anytime I say things are congruent, the next thing I can say is that their measures have to be what? Equal. So if angle 3 is congruent to angle 4, then what? The measure of angle what? 3 is equal to what? Measure of angle 4. You see how all of these are conjectures about the information given? And it's okay, as long as your conjecture translates to what happened, what they said, you're right. Could you have drawn four different linear pairs and had them be separate here? Possibly. Inductive reasoning is not foolproof reasoning. Let's say every morning, all year, I have come to school with a cup of coffee. What would inductive reasoning tell you is going to happen tomorrow morning? I'm going to come to school with a cup of coffee. Does that mean it has to happen? No. It's just saying the odds are what? That's going to happen. But tomorrow morning I could forget my coffee at home, couldn't I? I could simply, but lots of times inductive reasoning will lead you to a logical conclusion or something you need to think about, but that doesn't mean it's always going to happen. What we want to talk about now is this. Example, counter example. There's really not a dash in it, but I'm putting the dash to kind of separate the words. It's really one word. If I said to you, like I said, I brought a coffee every day to school. But you remember that on the third day of school, I didn't bring a cup of coffee. But every other day I have. If I made the blanket statement, I brought a cup of coffee to school every day. That's my conjecture. An example of this would be what? Anybody? An example of something, okay, is when you do something, isn't it? So an example of this would be all the days I what? Brought a cup of what? Coffee. What would you think then, what would logic tell you that a counterexample would be? A day that I what? How many ever been in an argument with somebody or with your parents' argument or just in the, and you say, remember then? Hey, that's a counterexample. I know your friend will probably say, oh, that's true, but blah, 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 blah. But every time you, but it's a specific example. A true counterexample would be if you said, hey, remember September 8th. That would be a counterexample. It's a specific example. It's not a general statement. Okay? It is a specific example. For instance, another thing I could say, all dogs have floppy ears. A specific counterexample with that would be my dog. He's a French bulldog. If any of you know what a Frenchie is, their ears go what? Up. He does not have floppy ears. Okay? So you would say Yogi Stump is a counterexample of that. If they ask for a counterexample. So it's not right when they ask for a counterexample to say, oh, all the dogs that don't have floppy ears. Well, no duh. That's kind of like, those definitions you give. Hey, what is a TV set? Well, a set that has a TV on it. You remember those days when you just do a definition and you try to use the words to make a, because you really didn't know what it meant? A specific example is a counterexample. Okay? So, looking back to our workbooks. Determine whether each conjecture is true or false. Give a counterexample of any false conjecture. Okay. So we're going to have to decide whether they're true or false. If angle ABC and CBD form a linear pair, then angle ABC is congruent to angle CBD. True or false? Well, okay, think of this. For this to be true, what would have to happen? They form a linear pair, so that means the two angles would what? Add together to get what? 180, correct? But I'm saying if they're linear paired, then they have to be, the only time that happens is when these are what? 90 degrees, right? That's an example. Well, it doesn't always happen that way, does it? So false, and they say, give me a counterexample. You could say the measure of angle ABC is equal to what? 60 degrees, and the measure of angle CBD is equal to, what would the other one need to be? 120? Isn't that an example of those two forming a what? Linear pair, but they're not what? Huh? You guys are just writing, I hope. Do you see that obviously angle ABC and CBD can't be congruent because they're not the same measure, right? So I would say false, and here's my counterexample. And I made a what? Specific counterexample. Is there going to be a lot of correct answers here? Absolutely. Somebody give me another correct answer for a counterexample. Come on.
Measure CBD is 60 and measure ABC is 120.
Very good. That would be another one, wouldn't it? Somebody give me another counterexample with different numbers.
Measure ABC is 70, measure CBD is 110.
Very good. They form a linear pair and all that. But they're not congruent, are they? Now, kind of what we're saying here is that they're supplementary, but what we're doing is it's already stated that they form a what? Linear pair. So we need to say things that would make it to where they're not equal. Okay? Number 10, if segment AB, segment BC, and segment AC are congruent, then A, B, C, and C are collinear. Will that always be true? Huh? See, here's the thing. In inductive reasoning, all you have to do is think of what? One instance where it doesn't work, and your statement is what? False. If you can't think of an instance where it doesn't work, then your statement is true. Instance or example. Can you guys think of a situation where that would not be true? Where A, B, and C not be on the same line? Okay. You guys know what a cube looks like?
Saying that they're on different lines and they're the same.
Yes, so you were saying, is there a situation where this would work? Or where these would be congruent, but they wouldn't be on the same line? Yes. I'll let you in a little secret. You know, an equilateral what? Triangle. Equilateral triangle where vertices are A, B, and C. So I'm saying these distances are all congruent, right? But are A, B, and C on the same line? No. So here's a counterexample. What about here? Is this false or true? Number 11. Hey, you know what you can do? You could make this 5, this 3. What does that make that? 8. Are A, B, and B, C equal? Huh? They're not. So our statement is what? If AB equals 5 and BC equals what? 3. AC is equal to 8. How about number 12? Angle 1 is complementary to angle 2. So the measure of angle 1 plus the measure of angle 2 equals what? 90. And angle 1 is complementary to 3. So the measure of angle 1 plus the measure of angle 3 is equal to what? Will the measure of angle 2 always be equal to the measure of angle 3? What do you guys think? Can you guys think of an example where it wouldn't work? Well, if measure of angle 1 is 60, what would that make at measure of angle 2? 30. What would it make 3? Huh? 30. Keep putting numbers in. Measure of angle 1 was 10. What would that make the measure of angle 2? 80. What would that make the measure of angle 3? What about measure angle 1 was 85? What would that make the measure of angle 2? What would it make the measure of angle 3? So each time, angle 2 and angle 3 are what's left out of what? 90 when you take away what? Measure of angle 1, correct? An algebraic way to prove that which this is an algebraic proof. See, I just subtracted measure of angle 1 from both sides. Is measure of angle 2 equal to the exact same thing that the measure of angle 3 is equal to? 90 minus the measure of angle 1. So they have to be what? Congruent. So this is true. Now, it is very important. Guys, you have to write the problems out. On this one, there's not very much abbreviation you can do. I want your answers separated from your problems. Your pictures don't have to be works of art. And I am going, here's what I'm going to start trying to do. I'm going to try to start cutting the assignments down a little, so I'd better see things done correctly. I'm cutting it down, and I've got to change it on Google. I'm going to cut it down to numbers 7 through 10, 14 through 27, and 40 through 44. Write the problem, draw the figures, show all steps, and work. It is not acceptable. I don't want to see a bunch of 1, 2, 3, 4, 5, 6. Have some space. Write it out. Have the answer underneath it. Circle it or box it in or highlight it. One of the two. Then when you grade and correct it, redo and try to figure out what you did wrong. Don't just write the answer from the book. Everybody understand that? To put it into perspective, what does the assignment say right now? Everybody turn on Google. What does it say it is? One through what?
1 through 13 all, 14 through 27 odd, 31 through 37 odd, 41 through 45 odd. And then write problems for all separate work and
So I guess it's close to the same. But I don't want to do odds because I want to see, because these are just one answer, it's too many of you are just writing down the answer from the back of the book. You need to try to do the work. But it's still not that many problems, is it? About 20. Let's get to work.